Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Question 8. Solve for x. The modulus of 4x plus 7 is less than 1. Okay, so again, a couple of ways of doing this one. A very common method used is to square both sides. Now, why? Why do we do that? Well, with these two signs, the modulus means that the answer to this could be plus or minus, but we typically take the positive case. In other words, the sign doesn't matter. Okay, so when it's an inequality though, we do care what sign it is. In other words, if we have a function in x that we're solving, such as this, x will be less than 2. Okay, but if I had minus 2x is less than 4, I need to change the sign across. Okay, and when I change the signs, in other words, when the sign of x is negative, it changes the direction of the inequality also. Okay, now as this is written, x could be a positive or a negative value. So when I'm solving it, it's quite hard to know whether this needs to change or not. Okay, so the easiest thing to do is square both sides. When you square anything, it makes it positive. So therefore, it removes the condition about unknown direction of the inequality sign. So square both sides. So I have 4x plus 7 squared being less than 1 squared, or 4x plus 7 by 4x plus 7 being less than 1. So I get 16x squared plus 7, 14, 28x plus 28x plus 49. I'm going to bring him over. Minus 1 is less than 0. 16x squared plus 56x plus 48 is less than 0. Let's divide across by 8. So 2x squared plus 8 7s 56, 8 6s 48. Okay, let's solve it. I might do factorization for change. I normally do minus b formula. So when I've got a number in front of the x, I take a by c. Okay, what do I mean by that? Well, this is ax squared bx plus c. I will take a by c to give me my guide number. So my guide number for this one is 2 6s or 12. Factors of 12, that gives me 7, 4 and 3. It's a plus 12, so, and it's a plus 7 in the middle, so plus 4 plus 3. Okay, is the way I need to go. So how this method works is the 2x squared stays the same. Instead of the plus 7x in the middle, you do plus 4x plus 3x. So they still add to give you your 7x, you just write them down differently. And you use the method of grouping to figure out your factors. Okay, so that's why the 4 went first there, because 4 and 2 are similar, 3 and 6 are similar. Okay, so group the first two together like you would have done in junior cert. So what's common between those two? Well, it's the 2x. What's left over? X there and 2 there. Okay, group the next two terms together. What's common between 3x and 6? It would be the 3 and the x plus 2. Okay, the brackets are the same, all is good. So group the outer two into one bracket. And then of course the inner 2 goes in the other bracket. So let's solve these for x. And these are what I always call my critical values. Okay, so 2x plus 3 is equal to 0, 2x is equal to minus 3, x would be equal to minus 3 over 2. Let's solve the other factor, x plus 2 equals 0, x is equal to minus 2. Okay, so not my solutions, my critical values. And it's always that when it's an inequality. So the easiest way I find to do this is to draw yourself a little Cartesian plane. mark in your critical values. So we have minus 3 over 2 and minus 2 thereabouts. Have a little look at your quadratic. X squared is a positive term, so therefore it's a smiley face. So draw in your quadratic as such. So that's minus 3 over 2, that's minus 2. Okay. And actually, before I draw in my quadratic, let me take you through what I'm doing here and how this applies, okay? So I'm going to color in this graph in two different colors, okay? Top, bottom, or the top is green, bottom is blue, okay? And I'm going to call the bottom area the area that's less than 0, and the top area is greater than 0. Now, what am I talking about when I do that? I'm talking about these y values that goes up here, okay? Your y values are your outputs, or you're supposed to your outputs to any function or equation. And can you see that all these values here are negative, or in other words, they're less than 0? Okay, so this is your 0 line here. It's where y is 0. So anything under that line is the area we consider to be less than 0. Above that line, all my y values, and it goes on forever, all my y values are positive or they're greater than 0. Okay, so that goes for any graph at all, that stands. Now, to come back to this particular question and to draw in this quadratic, okay? I don't know how far it comes down, but I know it crosses the x-axis at minus 3 over 2 and minus 2, okay? So let's draw it back in. Minus 3 over 2 there, minus 2 there, okay? So the question is, where is this graph less than 0? Okay, so we're only looking down this half of the region. So is it less than 0 between the two values or outside the two values? Okay, so in fact it's between the two values. So for any x value that's between minus 3 over 2 and minus 2, we are going to get an answer less than 0. We're going to get a negative answer. Okay, for any value which is less than minus 2, so minus 3 for example, or minus 4, or any x value that's greater than minus 3 over 2, we're going to get a positive answer, or we're going to get an answer greater than 0. Okay, so the solution to this question is 2x squared plus 7x plus c, 6 is less than 0 when minus 2 is less than x is less than minus 3 over 2. Remember, this function here is the exact same as this one. This is just a different way of writing this one. Okay, so that's the answer to that one. Okay, again, is there another way of doing moduluses? Well, yes, there is, or moduli, I should say. Okay, you can take the two cases where you consider what happens if it was positive answer, what happens if it was negative, okay? And you can solve them for x to get your critical values as well. And you'll get your minus 3 over 2 there. And in this one, we will get our, all right. It should be a 7. Again, I'm doing it in my head at the same time. And you get your minus 2 there, okay? So that's your critical values again. Okay, so instead of squaring both sides, you considered the sign. You took the case when it was positive and you took the case when it was negative. Okay, and we got our critical values. We still need to see, is our answer between these values or outside these values? So in many cases we can test a value. Okay, now the testing of a value takes a little bit of time to get your head around. So you can test a value between the numbers if you wish. Let's do that. So let's pick a value that's between minus 3 over 2, which is minus 1.5, and minus 2, which is minus 2. So a value between, an easy enough one, is minus 1.75. So let's test x equals to minus 1.75. And basically I'm testing to see if it satisfies this equation. Okay, so 4 times minus 1.75 plus 7, is that less than 1? Okay, so on my calculator, 4 times minus 1.75 is minus 7 plus 7 less than 1. 0 is less than 1. Is 0 less than 1? Well, yes it is. So therefore it is the values between these that satisfies this equation. So therefore any value between minus 2 and minus 3 over 2 satisfies the equation 4x plus 7 less than 1. Okay, so you might ask me, well, what does it look like if you test a value that's not between those values? Okay, so let's test another value, and one often used by teachers is 0. Okay, so you can see now that 0, which would be here, okay, is going to give me a solution greater than 0. Okay, we can see that because we have the luxury of already having the graph drawn. Okay, typically though, when you're using this method, you won't have a graph. So let's test x is equal to 0. So again, I'm going to sub it into 4x plus 7 less than 1. So 4 zeros plus 7 less than 1. 4 zeros are zeros, so I get 7 less than 1. Now 7 is not less than 1, so this is not true. Okay, so therefore you chose a value that was outside of this range. It did not satisfy the equation. Therefore, again, you conclude then that it's the values between the two values that satisfy the equation. The reason these are called critical values is everything happens with respect to these values. Okay, it's either between these values that satisfies the equations, or it's outside them. Okay, and that's why they're called such. So either method, whichever you prefer. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.